Okay, there's our objective. Here's a definition of what a time velocity graph is. All right. Now, here's our first example of what an object's doing. And an object, in this case, in the acorn of the object, it's not moving. So whatever line we draw needs to mean it's not moving. So here's the line we're going to draw, a line right on the axis. All right. That means it has a zero velocity, it's not moving. Now this guy or this family is cruising along, going on vacation, or maybe they're going camping, and this line charts their velocity. Now the thing about all these values is that they're all positive. What that means is they're all moving, excuse me, the object is continually moving in whatever you've deemed as the positive direction. It also has a positive velocity. Conversely, if you have this guy and you chart their velocity and you find this, all these velocities are negative after it leaves the axis. That that means the object is moving in continually in the negative direction, and it's continually moving with a negative velocity. Now remember this, the negative doesn't mean slow, it just means direction. Now, this object, this cheetah, is just pacing or pacing in front of his den. All right, if I were to chart this cheetah's velocity, I'd make a flat line. What does this flat line mean? All right, it could also look like this if he's pacing back and forth. You'll notice it's the same line except it's on the other side of the axis. These flat lines, regardless of what side of the zero value, be them positive or negative, they mean it's moving at a consistent rate. The velocity is not changing, it's not accelerating. Now, let's look at the velocity graph of a ball that's being tossed up into the air and then dropping. All right, what's that going to look like? This is going to be what its graph is going to look like. Look like. Look like. And I want to focus in on these areas of white, the lines, these straight lines. With the straight line with a slope, be it positive or negative, what that means is the object is experiencing a constant acceleration. Straight lines with a slope, be it positive or negative, it means whatever rate of change of velocity is the same, constant acceleration. In this case, the acceleration is the acceleration due to gravity. All right, now let's look at these two cars coming along. You can see there's a green light. Well, as the green light turns to yellow and then to red, what are these objects going to do? Well, hopefully they're going to slow down and eventually stop. So whatever line we draw up here on this velocity graph needs to show these objects slowing down. All right. Now what these lines are going to look like is they're going to be coming towards the zero, like that. All right. So when the line decreases in value, and by decreases we mean, or I mean, getting closer to zero, that means the object's slowing down. Now, when the light's red, it's a long light, and turns to green, what are the objects going to do? Well, the objects are going to speed up, or they're going to move away. So whatever line we draw needs to mean this. It's going to be the opposite of what we drew before, in that it's going to move away from the zero. They're going to look like this. All right. You can see both lines are moving away from the zero value or the x-axis, and that means these objects are speeding up or gaining velocity. Now, I want to show one other thing about the lines that we drew, and it has to do with the steepness. You'll notice which car gets to speed faster. Well, the yellow car, it moves a much greater distance. And the way that is shown is in the steepness of the line. That steepness tells you what the acceleration value is. And as we see here, the yellow is steeper, therefore it's accelerating faster. All right. Now, if I had a ball and I were to like wind it up and throw it, I'm going to impart most of my velocity at different parts and I'm going to accelerate it at different rates. Um, Therefore, the line's going to curve. Now, a curved line means your acceleration is changing. It's not consistent. Whatever rate of change you're giving the object, or whatever, what's not necessarily you, but what's being given to it changes. That's the curve. And one last feature of a velocity graph is has to do with displacement. Let's say we have a car and it speeds up. All right. Well, how would I show that velocity graph? I'd look at like that. All right. It speeds up at a consistent rate. It accelerates at a consistent rate. And then what does it do? It cruises along. How do I draw that? I draw a nice flat line. Now, I can calculate the area under the graph between it and the zero and the axis. This area is actually equal to the displacement. It's pretty cool. But you're essentially multiplying your time value by your velocity value. And that velocity times time gives you displacement. All right. And there you go. Hope this has been helpful. Let me know in any comments, please, what I can do to improve it. All right. Bye.